Okay, so in the last section here, I'm just going to prove this kind of a quick little theorem about how if the two one-sided limits at a point, a finite number, right, on the x-axis, if the two one-sided limits of f agree, then the two-sided limit exists, and it's the same as the two one-sided limits. And then on the other hand, if the two-sided limit exists, then both one-sided limits exist and they equal each other, or they both equal the two-sided limit, right? So it's a fairly obvious idea, but it's good just to like get it out of the way so that we can sort of use it however we want in the future, right? So this is 20.10 theorem. Let f be defined on J without point A. So of course this means that A is a finite number where J is an open interval containing A, of course. Then the limit, the two-sided limit of f of x exists if and only if the two one-sided limits exist. So it's not just that they exist, of course. If they exist and are equal, when these statements hold, meaning like all three of these statements, right? If all three of these statements hold, or all two of, I guess this is one statement, right? But if both sides of this if and only if statement hold, then all three of them are equal. All three quantities are equal. Okay. So first, yeah, the forward direction is very easy. So proof. Suppose the limit as x approaches a of f of x equals L, a finite number. Oh yeah, we're gonna deal with the finite case first, and then yeah, we'll deal with the infinite case later. So, right. So then, right. So they say, okay, clearly, right. So then the property, right, the epsilon delta type property of corollary 20.7 holds. So like if we let epsilon be greater than 0, then there exists a delta such that blah 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 for 0, for 0 less than x minus a less than delta, we have f of x minus L is less than epsilon, right? So clearly this delta can also be used for the epsilon delta properties of one-sided limits. And of course, in both cases, we end up using the same value L in the property as well. So clearly, the limit as x approaches a from the left of f of x equals the limit as x approaches a from the right of f of x, which equals L in this case, right? So this direction is kind of trivial because you just use, I mean, both of them honestly are pretty easy, but this one is even easier because whatever delta you get for the two-sided limit, you literally can just use that for both of the one-sided limits, right? On the other hand, suppose the limit of x as x approaches a minus f of x equals the limit as x approaches a from above of f of x equals L, a real number, again, finite, then by the epsilon delta. So yeah, okay. If we let epsilon be greater than 0, then the epsilon delta properties of one-sided limits tell us that there exists a delta 1 such that for a minus delta 1 less than x less than a, f of x minus L less than epsilon, absolute value, and for a less than x less than a plus delta 2, right? And yeah, okay, so there exists delta 1 and delta 2 such that the delta 1 satisfies the epsilon delta property for the left-handed limit, and the delta 2 satisfies the epsilon delta property for the right-handed limit for the given epsilon, right? We let epsilon be greater than 0. So we can pick these delta 1 and delta 2. And this is also making f of x minus L less than epsilon. Then for delta equals minimum of delta 1 and delta 2, for all x with 0 less than x minus a less than delta. Notice that this is equivalent to a minus delta less than x less than a, or a less than x less than a plus delta, right? So we have f of x minus L less than epsilon. So the two-sided epsilon delta property holds, and the limit as x approaches a of f of x equals L, right? The reason it's equaling L again is just because that's the same L that shows up in the epsilon delta property. So the fact that we proved the epsilon delta property for the two-sided limit with the same value of L means that it equals the same L. That's what I was trying to say before too, like over here, right? The fact that we can choose the delta using the two-sided epsilon delta property that works and makes both of the one-sided epsilon delta properties work with the same value of L, right, is why both of the one-sided limits equal L, okay? So anyway, that's, at least that's the case for finite numbers. And then like for infinite, the infinite case, like if these both equaled infinity, then there would just be like delta 1 and delta 2. You'd let m be greater than 0, or let m be a real number, right? And then there would exist. So let's say, now I'm going to just like, actually, I'll just like write over here with red. So if this was infinity, we would let m be a real number such that f of x is greater than m. And then this is like also f of x is greater than m, right? And then this is all true. And again, we would have f of x greater than m here. And then this would be infinity over here, right? So it's very trivial to modify the the proof to account for infinite limits. And the same goes for this one, right? So if L was infinity here, you just say, then this would be M and R again, and then this would be f of x greater than m, and then this would be infinity, right? So same thing. Anyway, so that's it for the limits, for limits of functions. That's a wrap. So thanks for watching, and I'll see you in the next lecture.